I saw this post on LinkedIn the other day. The post is made by Chris Long, and he noticed a really cool thing about Gemini's API. It looks like this query fanouts are basically exposed within the grounding metadata, which means that we can see the actual search queries that the AI is using as it is checking the web to provide the answer. For an SEO, this is a massive opportunity because it allows to see how the AI is searching, which means we can optimize for AI. And in this video, I want to go deeper into this specific setup over here. We'll do multiple tests. And related to Chris over here, unfortunately, I don't know this person, but I thought it was a really great find. So I give all of the credit for him, as this is where I learned it as an initial source of information. So we're going to have to run some code. Over here we have a simple request for the Gemini API. We allow it to use the Google search, and primarily we care about this web search queries, which are exactly the query fanout, as Google is calling them. We're going to collect them, and then we're going to print them out one by one to see exactly how it is breaking down the query and what is exactly happening under the hood. For now, we're going to use this request over here, which says, find me the best glasses for marathons. For now, let's just run it and see what we're going to get. And over here, you can see we have these two queries. One of them says features of good marathon glasses. The other one is best running sunglasses for marathons. At the, let's say, as the initial impression, this looks like a gold mine because we can actually see precisely what is being searched when something like this appears within the request. But as I did a little bit more testing, I noticed one of these elements. Let me try to replicate them. So notice I'm not changing anything within the configuration or the code. We have exact same query. The only thing we're going to do is we're just gonna rerun this part over here. Let me also save this initial response that we received, so you can see it as a kind of like history in terms of what we received in the first place. And let's test it a few times. So let me run it again. And on the second run, you realize that we have a completely different set of these queries. So over here, let's just say, if we compare them side by side, this came from the first attempt, this came from the second attempt. Totally different variety, totally different set of these queries. This already signals at least, let's say, multiple different things. First of all, what I understand is that these are not, let's say, real queries. They're not coming from some kind of existing proven data set. These are just generated by AI, which means these are just technically hallucinated queries that are imitating a user search. So if you have this kind of strong inconsistency between the requests, it becomes way harder to create some kind of clear, let's say, median or a central part that is really, let's say, reusable. So let's just test this a little bit further, and let's convert this query towards something that really doesn't make any sense. And let's just ask for, let's say, find me the best marathon glasses for red parrots that don't sing hip hop or something like that. And over here you can see the expansion that we received. So first one is saying marathon glasses for red parrots, and the second one says best marathon running glasses for bird. If we're gonna look at all of this conceptually, first we have the real query. The word real here is the key one. It comes from the user, and we know there is a kind of multiple, let's say, intentions or a very specific demand over there. These queries need to be expanded or split into something more minimal or something more precise. This is where you exactly see these query fanouts, what I just showed you within the code execution. The problematic part, as you saw, the consistency on this level is a little bit, let's say, shaking. It's very unstable. But for now, let's say, simplify it and stick to the process. So main query, then it is converted into multiple variations. And then we finally reach the search engine level over here. So we have the same query as over here. And now we need to find a match from this query to the document. Over here, there could be lots of different documents that are all, let's say, potential candidates, but we need to find the match for the absolutely best one. So now comes a very important element. Whenever you have, let's say, a few candidates and all of them make sense, you have to actually re-rank them to find the best one. Let's say if you only have one candidate, that's obviously your single match, you just go with that. But as you just saw over here, if we have an expansion like this, best marathon running glasses for bird or marathon glasses for red parrots, what are we supposed to find over here? What if this document doesn't exist at all? What will the search engine actually do over here? If you don't know, I have good news for you, because I know a person who knows the answer.
If you search something like, let's say, the most expensive or the most luxurious electric cars in Asia, let's say, if the search demand for this complete section is too low, Google usually takes this and directly blend it together with a higher topic.
So what happens here is that there is a hierarchy of these documents. Let's say if we're asking for something hyper-specific like marathon running glasses for red parrots, we're trying to match something over here, but this does not exist. That means within the, let's say, nature or the existing setup of the search engine, it will go up in the hierarchy to find the next closest match, if this is 0. So if this was, let's say, an attempt to find marathon glasses for red parrots, over here can be, let's say, accessories for parrots, or maybe things like toys for parrots. And let's say for some reason if this doesn't exist, then it can go for, let's say, accessories for birds. If this does not exist, this will go to, let's say, accessories for pets, or a kind of pet shop, or things like that. So there is always a kind of fallback, let's say, mechanism, or the next probable set of documents that is most likely to serve this request over here. This is very important to understand, because most of these queries that are coming from the LLMs are exactly of this type of nature. There will be no documents created for them specifically, and within the actual search process, there will be a kind of fallback that will just steer the information towards the most probable information that exists over there that will be used to actually serve the request. So then you can say, wait, but yes, there are no documents for these queries, but what if I create my documents and they will have all of these variations that we just saw over here? The problem with that is, in reality, over here, within this example, we're looking at a very tiny data set. So first of all, if you saw that if we do like multiple reruns, what happens is that there is slight, let's say, overlaps within these expansions, and it creates this kind of, let's say, messy kind of bubble of information. And this is just given that we're only looking at one single query. Because these queries are, let's say, very, very specific, if there is lots of users that try to perform these, let's say, slightly different searches, this bubble will start to be expanded way further, which means the amount of all of these possible variations that exist are just too massive to try to capture all of them within your documents or within the website itself. But there is something that, let's say, we can do in a much smarter way to try to capture this approximate bubble, and that's what I want to show you within this part over here. So first, let's return to this initial query that we had over here. Second, instead of doing a single request, we're going to change it towards something slightly different. So what we will do now is we still process the exact same query that we were requesting initially, except this time we will call it 20 times automatically. We will track it as first run set of query fanouts that we received. Then second run, third run, and etc. for 20 runs. And then we'll see the actual repetition for these expansions, or let's say these query fanouts. And then we can come to some certain conclusions. So let me run it. All right, and here we have the statistics. As you can see, we have these different runs. For each and every single one of them, we have the query fanouts. And finally, down here is the most important part. So you can see that a phrase that says best running glasses for marathons has appeared 10 times. Ironically, this is exactly a human-like, very natural query that will be already existing. If you're following proper semantic SEO and you're building a proper semantic content network, you will be touching or affecting this query naturally. So there is nothing that really is changing within your strategy. However, if we look for something, let's say, like features of good glasses, this is slightly more different or slightly more unique. It might not appear within the real queries, but you can see that there's a somewhat significant chance that AI might want to steer the direction towards that thing. And this is where you can create extra levels of relevance. And then, of course, something like best running sunglasses for marathons is this exact same case as this point above over here. And this is the overall pattern that I've observed thus far. There is a very, let's say, thin line over here when there is some kind of opportunity. For the most part, it doesn't seem that strong or that different, because ultimately what this LLM is trying to do is become as closely as possible towards these human-like behaviors in the first place. So this might be beneficial to test and experiment with. However, as you can see, there is not that much big of a kind of gap or something that is definitely missing over there, at least if you're following the proper semantic SEO principles. If you understood the video thus far, up until this point, I definitely can say you're one of the smartest people in the SEO industry, which is why I would be very happy to stay in touch. I recommend you to go to serp.science and sign up for the mailing list. This way we can communicate more privately, and that definitely makes things much better. Now, related to this part, if you want to take this much more seriously, one key element that is missing from this whole setup is the actual model that is being used to create these generations. So if we look at, let's say, one of their research papers, over here you can see this comes from the November of the last year. This talks about this RAG setups, which is exactly the, let's say, summarization of documents. Over here, they're still testing the Gemini 1.5 Pro and Gemini Flash. So even though much smarter models exist, like 2.5 and 3, I believe at this point, the experiments are still done with the smallest, cheapest models that exist. If you look at their official statements, if we can trust them, within, let's say, a few recent days, on January 27th, they've actually mentioned that now they're making the Gemini 3 as the default model for all of these AI overviews systems. It's up to you to make the decision which model to go with, and let's say there are different ways to verify these things, but you can see there is, let's say, different angles that can be perceived over here. And lastly, to summarize this overall, let's say, logic over here, so technically, if you're aware of what kind of user behaviors exist, exactly these kind of long tail queries, and you're able to create some kind of, let's say, similarity within these groupings, then you can do a kind of rerun on this code that I just showed you, which will allow you to create this bubble of fanouts for all of these similar behaviors. And then you have those, let's say, tiny elements that potentially might be useful for you to create a kind of slightly better tuning of your documents to actually create a higher chance to create a kind of a relevance on this level. The tricky part lies over here. And then because these queries are all hyper, let's say, contextual, or they're hyper specific, it might be very hard to create these kinds of groupings, which is why it's a little bit, you're always running in a risk of bloating the pages with something that is really not that much useful. And the most important part over here when it comes to these groupings is the actual popularity. Because if there's something that's being requested once in 6 months, it's really not the point of trying to optimize for it. Which is why, again, we're trying to infer the most popular statistics on this level to just create that higher chance to protect yourself from, let's say, bloating the site or bloating the pages. I hope this is helpful. And lastly, if you watched this video up until this point, I want to show you one more paper, which is somewhat relevant towards what we were talking about over here. So in October 2025, Google's research team has done a very good analysis of users' needs and actions within these AI setups and AI summarizers. And basically, they have a very, very clear, let's say, configuration or a pattern that they have inferred from a bunch of data that they've looked at. Over here is a very clean and clear representation. So you can see there are 3 different layers that all have different modes of behavior of the AI and the actual users, let's say, requests or demands that appear on these levels. A much more important part is listed somewhere down over here. They show you these same modes of behavior, and also they show you a kind of level of cognitive ability that is required of the LLM to do a good enough job. So for example, for something like information seeking tasks, it actually requires a very, very low level of, let's say, cognitive ability to do a good enough job, which means this part over here, generating these query fanouts and then basically summarizing the actual information that has been retrieved. And by the way, whether the query fanout generation and summarization is done by the same model is also kind of remains a question, because that might be 2 different models that do this type of cooperation. Also, you can see over here that, let's say, for things like content production or content creation, it requires a very high level of ability, which is why they would be most likely to use the strongest model in order to satisfy the user. So it's just a very good, let's say, framework or a kind of template to understand how Google perceives the web and where they are most likely to use which types of models. With that said, I hope you found this video useful, and I hope you learned something new, and thank you so much for watching.